Hello everybody, welcome to the JavaScript course. In this video, I'm going to talk about how to set up a loop. So basically, there are three types of loops: for loop, while loop, and do while loop. And we can also use the keywords like break and continue to control the looping. And finally, I'm going to talk about a property of JavaScript by means of labels. With labels, we are able to exit a loop as we wish, as long as the loop is indicated by a label. Now, let us see the HTML file first. The HTML file is very simple. It just contains a title together with a heading, and this HTML file is going to link to a JavaScript file stored in the JS folder, and the file name is simply called myscript.js. And the JS folder is at the same level of the HTML file. Okay, so this is the setup of the HTML file, and I'm going to discuss the JavaScript file. Now, this is the JavaScript file. In order to use the strict mode, I have to say use strict at the very beginning of the JavaScript file. Okay, and then we can do our discussion of loops. The first one to talk about is the for loop. So a for loop is quite simple. And let me set up an example, and then I can illustrate it to you. So now I have a for loop to show up the alert windows. The mechanism is like that one. I have to set up a variable for the loop first, which is k in my case, and the value of k starts with 0. So this is the initializing action of the for loop, and this is the condition for the for loop to execute. We have to make sure that k is smaller than 4 in order to allow the loop to execute. And how can we update the variable? We can do something like this one, k++. It means that k will be updated by a value which is just 1 larger than the previous value. So k will be actually 0, 1, 2, and 3 in order to allow the condition to hold. When k is larger than or equal to 4, this condition is violated. That means we don't do the for loop. So we can expect that we will print out 0, 1, 2, and 3 by individual alert windows. So let me save it and run it to see the effect. Save, reload. Yes, 0 first, which is the initializing condition. 1 is simply the update result. 2 is the another update. 3 is also another update. And now k is 3. And this condition still holds because 3 is smaller than 4. But how about when k is further updated to 4? You see, the alert window doesn't show up because 4 isn't smaller than 4. This condition is violated. In this case, the for loop stops. So that is the simple way of setting up a for loop. We do the initializing variable inside the for loop declaration. Okay. Actually, we don't always need to specify all these 3 conditions in the for loop. So we can set up an example like this one to explain this particular situation. Now I have another for loop, but I don't have the initializing condition at the beginning of the for loop. Why? Because I want to do the variable declaration before I enter the for loop. So I would say that I is the looping variable, and the condition to allow the looping is that I has to be smaller than 4. So when I is 0 at the beginning, we can allow the looping. And how can we update the value of I? We just do I++. So this variable I is already defined outside the for loop, or even at the beginning of the for loop. So we can simply pass the variable which is defined before the for loop to the declaration part of the for loop. Okay, so we still have 3 parts: the initialization, the condition, and the update. But the first part, which is the initialization, is done outside or even before the for loop. So this I corresponds to this I again. And effectively, we can also print out the 4 other windows as shown in the previous example, like this one. Okay, so let me save and run it to see the effect. Save, reload the page. 0 first because I start with 0 and 0 is smaller than 4, so this condition holds. The alert window can be printed out. 1 is printed out because the alert window content becomes 1. 2, 3, and how about 4? When I click on OK, I don't print out 4 because 4 is not really smaller than 4. So this condition fails, and when the condition fails, I don't do the content. So I don't print out 4 as the output of the program. Okay, so that is the idea of the condition when the for loop doesn't have the starting condition stated explicitly inside the for loop declaration part. Okay. Even more, we don't really need to mention the variable update part shown here. So let me see an example to illustrate this particular effect. Okay, how about this situation? I have a variable defined before the for loop, which is j, and j is actually the loop variable to be used in the for loop. And in the for loop declaration, I just have the condition stated inside, which is j smaller than 4. And I don't even need to include the variable update part. But how can I do the update if I don't specify the update inside the for loop declaration? Actually, I can do the update inside the for loop. Okay, so the content for the for loop includes the part to do the update. Okay, so the effect is the same as the previous 2 for loops. I'm able to print out 0 to 3 by 4 individual alert windows. So let me save it and reload the page. 0, which is the first value of j, and since 0 is smaller than 4, the condition holds, and the condition allows me to print out the alert window. Now, j becomes 1 because this part has already updated j to 1 from 0. And since 1 is smaller than 4, I'm able to do the showing up of the alert window. Same for number 2, same for number 3. And now j becomes 4. Is it able to do the alert window for j equals 4? No, because this condition already fails when j is now 4. Okay, so we can see that for the for loop declaration, we don't always need to include every single part of the setup. So the variable initialization and the condition and the update part don't need to be present all the times. But in general, it is better for us to use the general idea at the very beginning of the video. That means we include all these 3 parts at the beginning of the for loop declaration. That is the more general way or the more accepted way of setting up the for loop. And the later 2 approaches are less popular. So we can simply stick to this one if you think that simplicity or readability is more important. Okay. Now we are going to talk about the while loop. So we have already talked about the for loop, which follows the loop variable to do the changes accordingly for each of the iterations. The while loop is quite similar in this sense. And let me set up an example to show you the effect of a while loop. Now I have a while loop saying that I have to always check the condition to see whether a is smaller than 4. So the while loop is something like this one. We execute the loop content when the condition is satisfied. Okay, so when this condition holds, I'm able to do the content inside the while loop. If that one already fails, I don't do any longer. So A is already set up before I go to the while loop, and we can expect that A will be incremented by 1 after each iteration of the loop content. So at the beginning, A is 0, so 0 is smaller than 4. I'm able to print out 0. So the printing of the alert window continues until A becomes 4. So let me save it and reload the page to see the effect. 0, 1, 2, 3, and how about 4? No 4, because when A is updated to 4, this condition already fails, so this while loop content won't be executed any longer. So that is the idea of a while loop. We execute the loop content when the condition is satisfied. So that is the basic idea of a while loop. So the while loop is quite similar to a for loop, but usually when we don't exactly know the number of times we need to do the looping, we may rely on the while loop to help us do the iteration. So when a condition is no longer satisfied, we can stop the looping. And this while loop is especially useful when we don't exactly know the number of iterations to do before we really run the program. Okay, so for the for loop, actually we can already know the number of loops we need. But for while loop, we don't always know the number of loops we need beforehand. Okay. Another loop is called the do while loop. As opposed to the while loop, the do while loop has to execute the loop content at least once. So let me see an example. So the while loop condition is placed at the end of the loop. So we have to do something inside the curly brackets, and after doing the things inside the curly brackets, we check whether the condition still holds. Okay. So we have b equals 0 before I really set up the do while loop. And we can expect that the value of b will be printed out by the alert window. So after the printing, I will increment the value of b. And I have to always check whether b is still smaller than 4 after the update. Okay, so we can expect that we can print out 0, 1, 2, and 3. Because when b is already updated to 4, the condition shown here will fail. So let me see the effect. Save. Reload the page. 0 first, because it is the initializing condition. 1, 2, 3. And how about 4? No 4, because when b is updated to 4, this condition already fails, so I don't need to re-enter the do loop again to print out 4, and I just end at number 3. So that is the way we have to use a do while loop properly. And I repeat, we do the loop for at least once, because at the very beginning, no matter the value of b, I have to enter the do while loop at least once. Only when this condition is checked to be unsatisfied, after doing the first trial, I will consider whether to do the looping again. Okay. Okay, let us talk about a keyword called break. We don't always need to do the for loop or while loop continuously for all the iterations specified by the loop variable. We can simply leave the for loop or the while loop and run the code following the loop if we can make use of the break keyword properly. So that is the idea of using a break keyword. As an example, I'm going to show you a situation to use a break keyword now. So now I have a for loop and I'm going to print a prompt, and I'm going to accept a value from the keyboard, and I'm going to store the value to the variable called value. Okay. And what will I do after the prompt is already obtained? Okay, my idea is like that one. If the value obtained by the prompt window is exactly equal to 8, I'm going to say that the value is correct, and I will break the for loop. That means I'm going to leave the for loop and I'm going to do the rest of the code just after the for loop. So in this case, I don't need to really do the looping for 5 times as specified by the loop variable called m. So let me see the effect by running it. Save, reload. Suppose I guess 2 for the first time. I have to do the guessing again because 1 is not equal to 8. And how about 3? Well, it still fails, so I have to guess the value for the third time indicated by m equals 2. How about 4? I still need to do the looping again because I can't get the answer correctly. And how about I set up 5? I still have to do the input again because for the 4th time I still don't input 8 as the answer. And how about 6 here? You see, I have already failed for 5 times, so the looping already completes. I have already run the for loop content exactly for 5 times, because for these 5 times I have never guessed the value correctly. Okay, so how about a situation when the number can be guessed correctly within 5 trials? Let me run it again. So I say 2, so this one fails, and how about I put 8 as my second trial value? Okay, I say correct, because value is equal to 8 exactly. And I will break the for loop so that I don't go back to the beginning of the for loop to do another request for the value coming from the prompt window. Okay, so the for loop ends. I don't need to go to the for loop for the 3rd time to do the looping again, because I've already broken the for loop by using the break keyword. So I'm going to do the rest of the code just after the for loop, okay? So that is the basic idea of using a break keyword. Another keyword is called continue. It is different from the break keyword. For the continue keyword, we can simply skip a certain iteration and go to the next iteration. So let's see an example to see the meaning of the keyword continue. So I have a for loop and I have a continue keyword inside the if condition shown here. So we can expect that the value of n would be from 0 to 4 in order to allow the for loop content to execute. And when n is equal to 3, I don't do the alert window showing up here, because when I see the word continue, when n equals 3, I will go back to the for loop to do another iteration. So n will simply become 4 after n equals 3. And in this case, I don't do the alert window. So let me see the effect by saving it first. Save, reload the page. 0 first, because n equals 0 and 0 is not equal to 3. I will just do the alert window. 0, 1. Same for 1. Same for 2. And how about 3? You see, I don't have 3 as the output, because when n equals 3, I go back to the beginning of the for loop and I'm going to do the next iteration. So n will become 4. And when n equals 4, I'm going to do the alert window showing up here. And in this case, we can see that we can skip n equals 3 because of the continue keyword. So when I press OK, I have already ended the for loop, because n is now equal to 5 instead of 4. So the looping ends. So this is the important property of the continue keyword. We don't do a particular iteration, and we can go back to the beginning of the for loop to do the next iteration. Okay. Another property is called labels. A label is simply a name for a certain loop, so that we can leave a loop indicated by the label directly. And by means of this property, we can simply leave the outermost loop immediately by not leaving all the nested loops one by one. So let us see an example to see how the labels can help us do this kind of effect. So I want to call this while loop the outermost loop. So I give a name to this while loop. And if I want to leave the entire while loop, I can have something to add inside the while loop first. Okay, I have a nested while loop as follows. If q equals 3, I will simply break the outermost loop so that I will simply leave the outer while loop and do the alert window showing at the end of the program. Okay, so actually when we have a break keyword, we simply leave one level of the while loop or the for loop. So initially, if I don't include the outermost loop label, when I do the breaking action, I just leave the while loop, which is the inner one. Okay, and I'm going to do the printing of the value of p by using the alert window just after leaving the exactly one level of the while loop. So let me see the effect of including the label and ignoring the label. Okay, so for now I do the label first. Sorry, the while loop, which is the outer one, should be q smaller than 4 as the condition. And for that one, q should be smaller than 6. Sorry about that. So I've got some typo. And let me save it to see the effect. Save, reload. Yes, I will see q equals 0 at the beginning, because when p is smaller than 4, and while q is smaller than 6, I can do the alert window shown here. Because q is not equal to 3 right now, I can say q equals 0. And when I press OK, I will say q equals 1, because I'm still doing the inner while loop, and q becomes 1 after the update. How about another iteration? Q equals 2. And how about q equals 3? We can expect that we will simply leave the outermost loop indicated by the label here. So I'm going to show the end of loops. Is it really the case? Yes, this is really the case, because when q equals 3, I don't just quit the inner while loop, I'm also able to quit the outer while loop as well. So in this case, I'm going to do the rest of the code. So we can see that we print out the end of loops. Okay. So how about the situation when I don't include the label? Let me save it and reload the page. Q equals 0, Q equals 1, Q equals 2. And how about now? When Q equals 3, I just leave the inner while loop, and I'm going to do the rest of the code just after the inner while loop. So I'm able to see that I'm able to print out Q equals 0. P equals 0. And the next one will be P equals 1, because I've already left the inner while loop, and I'm going to do the rest of the code indicated by the outer while loop. P equals 1, P equals 2, P equals 3, and how about P equals 4? The while loop condition will be failed, so I'm not going to print out P equals 4. Instead, I will simply say that I will end the loop, because I've already quit the outer while loop as well. So I'm going to do the rest of the code indicated by the alert window on this line. Okay. So this is known as the label. When I have the label, I'm able to quit the loop indicated by the label name. Okay, so that's the idea of a label. So in this video, we have already talked about so many properties of loops. We have talked about the for loops, and we have also shown the situation when we don't include all the 3 components of the for loop declaration, namely the initialization of variable, the condition for the for loop to execute, together with the update of the loop variable. And I've also talked about the while loop, which is a way to execute the loop content when the condition is previously satisfied. We have also talked about the do while loop, so that we can guarantee that the content of the loop will be executed at least once. And we have also talked about the break keyword to help us leave the loop and do the rest of the code. And we have also talked about the word continue, which helps us to skip a certain iteration and go to the next iteration. Finally, we have discussed the word labels, which is a pretty convenient way to control the loop departure. When we include the label, like this one, we can just leave all the levels of the for loop or the while loop so that we can do the rest of the code just outside the loop indicated by the label. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.